Bluebot's Journey to the Star. Hi, I'm Lauren Kritzinger.
I'm Balkis.
And I'm Mark.
Within our design unit, student learning is scaffolded across 3 lessons to gradually release students' responsibility towards the use of digital systems. This unit will provide students with rich learning opportunities through the integration of constructivist pedagogies, including play-based learning, problem-solving, and inquiry-based learning.
The unit is based around the book Helping Little Star, which provides students with an engaging fictional context. The story follows the journey of Little Star as he tries to get back to his home with the help of his friends after he falls out of the sky.
The unit offers students the opportunity to engage in higher order thinking skills, computational thinking methods, collaboration, and communication.
Bluebots are a programmable floor robot which allows students to use command keys to send the robot in any direction across the floor. Bluebot's simple layout allows students to use push buttons for an iOS app to explore computational thinking and digital systems.
By the end of this activity, students will be able to use digital systems to create simple algorithms to produce design solutions in order to create and represent a logical sequence of steps that detail Little Star's journey.
Computational thinking describes the processes and approaches we draw on when thinking about how a computer can help us to solve complex problems and create systems. It helps to break a problem down into smaller, more manageable components to understand what a problem is and develop possible solutions. The cornerstones of computational thinking include decomposition, pattern recognition, abstraction, and algorithms.
In the engage phase of the lesson, students are introduced to the book Helping Little Star. Students delve into digital systems, directional language, discuss backtracking, and practice using relevant terminology that matches directions. This is achieved through the activity where students act as human bluebots and must follow directional commands that are given to them. Not only does this allow students to decompose a system into smaller parts that are easier to understand, it also gives students the opportunity to examine directional commands specific to the digital system. Once students gain confidence in using directions, they are then introduced to bluebots and the teacher models how it works. Students are then encouraged to engage in play-based learning to explore the various capabilities of the system. The activity requires students to partake in collaborative, hands-on learning while engaging in active problem-solving. Ultimately, this phase of the lesson reinforces the concept of decomposition and provides the foundation for students to be able to partake in more complex tasks in further lessons. Students are also exposed to algorithms and discover the language of coding through inquiry.
Students will be constructing explanations of the concepts and processes about directions, instructions, and coding. Students will be revising the main concepts of understanding and increasing their knowledge, instructions, and directions. They will be collaboratively learning by working in groups, showcasing their skills in the content by recognizing patterns, directions with hands-on learning, problem solving, and understanding why directions are so important. Students are able to make links to the computational thinking skills by identifying the pattern recognition of where do they see a pattern of how the bluebot moves direction. They will also be developing the cornerstone of abstraction. Abstraction is the process of filtering out, ignoring the characteristics of patterns, and students will be looking for a small pattern to try and help them solve the bigger problem.
Lesson 3 involves bringing together the skills and knowledge built over the previous lessons to solve a summative task. The task is for students to plan, program, and execute a journey of their bluebot through a map, whilst adhering to certain conditions and constraints. The students are placed into groups and are to work collaboratively to construct an algorithm that will guide their bluebot, or Little Star, through the map to get back into the sky. Groups are to independently plan their sequence of directions, test out their journey on their iOS app, and program their bluebot digital system to maneuver throughout the map. For the second part of the session, students evaluate their learning by pairing up with another group to peer assess their sequence of directions and program them into the bluebot. Through a peer assessment, students will evaluate the design solutions of their peers and discuss any errors in pattern recognition or programming. Students work collaboratively to develop a step-by-step solution to the task by creating, testing, and re-examining simple algorithms to program their bluebots through a specific map. Students will need to follow rules in the forms of conditions and constraints to guide their bluebot directional sequence. Students will learn algorithmic thinking by understanding that rules need to be followed and steps must be made to get a solution. Students develop their literacy skills through listening to and reading Helping Little Star. They develop their numeracy skills through pattern creation and recognition and the use of directions to program a system. They develop their ideative thinking is fostered throughout the unit as students evaluate their knowledge to problem solve their bluebot journey. Students look at personal and social capability as they explore healthy friendships and work collaboratively in teams to handle challenges. Finally, students build intercultural understanding of Indigenous perspectives, their culture, beliefs, and how it interconnects with students' own culture.